And today we will continue to solve some exercises from mechanics, and on our next seminar we are going to start electricity and magnetism. So today we are continuing mechanics. And we will take exercise number 14. Exercise number 14 from mechanics. Exercise number 14. Sorry, I will take description. E number 14. According to the description, a cylindrical disc of a gyroscope of mass m and radius r rotates with the angular velocity omega. The distance between bearings in which the axle is fixed is equal to L. The axle is set into harmonic oscillatory motion with the period t. And the amplitude phi m. Find the maximum value of the gyroscopic forces which act on the bearings. So according to the description, we have system that can be shown here. This is a disk. This is the disk view from a side, and here the axis of rotation. And we can sign here omega. Bearings can be shown like this. And this the cylinder axle of rotation is fixed, but it is set into harmonic oscillatory motion with the period t and the amplitude phi max. So we have velocity of precession velocity, and it can be shown like this. we also have precession. We have precession. We have precession, so maybe you have some ideas. Maybe you have some ideas how to solve this exercise.
Sorry, teacher, I don't know.
Okay. 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 So maybe it is possible to remember. There is a formula for the moment of gyroscopic forces. Moment of gyroscopic forces is equal to I is moment of inertia. I is moment of inertia, and here vector product or cross product, it is the same velocity of precession and velocity of rotation, angular velocity of rotation. And so moment of inertia. The disk has a cylindrical form. It is a cylinder. Maybe you can remember a formula for the moment of inertia of the cylinder. Moment of inertia of the cylinder. We have already formula for this. We don't need to obtain it from integral, because we have already result. Can you remember this? Moment of inertia of a cylinder in relation to its axis. No. Okay. It can be written as m r radius in second order divided by 2. Okay, and what about the direction of m? Direction of m according to this formula. Maybe you can remember this. Direction of m. Cannot remember. Okay. I have forgotten to draw a distance between bearings. The distance between bearings. The distance between bearings is equal to L. It is equal to L. Is equal to L. Okay, but if we have vector product, vector product. How to how to find the direction of vector product. It may be done. It may be done with right hand rule. With right hand rule. According to this, for example, if we have two vectors, on the screen, a vector A and vector B, and for example, vector product A, B, vector product A and B will have direction that is perpendicular to the screen, and it is from us to the screen. It is from us to the screen. From us to the screen, according to the right hand rule. According to the right hand rule. And what about cross product B A? What about its direction? This direction will also be perpendicular to the screen, but it will be from the screen to us, and it can be shown like this. It can be shown like this: the direction of B and direction of cross product B and A. Okay, it will be some information. It was some information about vector product. And okay, what about the direction of this vector product? Can someone find the direction of this vector product according to the right hand rule? Or maybe right screw rule? But it is a direction of rotation. It is a direction of rotation. But I am asking about the direction of this, vector. about the direction of this vector. Because vector vector of angular velocity of precession here, it is directed from us to the screen. It is from us to the screen, and the direction of angular velocity omega, it is shown on the screen with this vertical arrow. It is shown with vertical arrow. And so how to find the direction? How to find the direction of M? The direction of M.
Teacher, I don't know.
Don't know. Okay, according to right hand rule, it will be turn. It will be shortest turn from omega p to omega. From omega p to omega. So this turn, it will be this turn, and the direction of this turn is here. Maybe it is necessary. It is necessary to repeat something about the properties of vector product. About the properties of vector product. Okay, we have solved the situation with the direction of different vectors, and but we have to find the modulus. We have to find the modulus of this moment. The modulus of this moment. And so we have to find modulus, and it is equal to modulus of a vector product Okay, maybe you can remember how to calculate this. And maybe you can remember how to calculate this. No, it is not what we need. It is not what we need. We need to open this vector product. We have to open this vector product. So I mean this. According to the properties of vector product, we can write sinus, and what angle do we have here? What angle do we have according to the picture? According to the picture that is shown on the left side. Because omega, vector omega is shown with vertical arrow, and omega p is shown with cross, in a circle, and it means that omega p is perpendicular to the screen and is directed from us to the screen. And what angle between these vectors, between omega p and omega? Nobody knows. Nobody knows. But if omega in the screen and omega p is perpendicular to the screen. So according to this picture, we have omega is perpendicular to omega p. Because omega is in the screen and omega p is perpendicular to the screen. It means that, oh yes, it will be 90 degrees. Okay, it is 90 degrees, and according to this, we have I omega p omega p and omega. Okay, so we have moment of inertia is m r in second order divided by 2, and so we have moment of inertia, we have omega according to the description of the exercise, and but we have to find omega p, angular velocity of precession of the axle, so in the description it is said that axle is set into harmonic oscillatory motion with the period t and the amplitude phi m. What does it mean? Harmonic oscillatory motion. It means that because we haven't learned this yet, but I'll show the formula. Harmonic oscillations mean that it can be described with formula. Phi is equal to amplitude phi m multiplied by cosine of 2p divided by the period and multiplied by time, and plus some initial phase initial phase phase alpha. Initial phase alpha. This is a dependence. This is a dependence of angle. The dependence of angle. Angle of angle of precession. Okay, and according to the description, we have harmonic oscillations. And how to find omega p from this? How to find omega p? Velocity of precession. It is necessary to remember kinematics, and it is necessary to remember the connection between angle and angular velocity. It is necessary to remember the connection between angle and angular velocity. The connection is here. It is a derivative. It is a derivative dphi by dt. By dt phi m cosine cosine 2p divided by t plus alpha. Okay, now it is necessary to remember the calculus. Remember calculus and to find this derivative. Can you find this? Can you find this? Okay, what about the derivative? What about this? Can someone remember this from calculus? From differential calculus, it was oh yes, it will be sinus sinus of x. Sinus of x. Yes, it was your first year in university when you have learned this. Okay, that's correct. That's correct. So now it is necessary to use this. It is necessary to use this here. To use this here to find this derivative. How to do this? How to find this derivative? Yes, Vm. Okay, that's correct. That's correct. That's correct. So according to this, we have minus. Maybe I will move this to the left. Move to the left. Minus 2p phi m divided by t sinus sinus 2p divided by the period t multiplied by time plus initial phase alpha. And so this is angular velocity of precession. But according to the description, we need the maximum value. We need the maximum value. We need the maximum value of this maximum value. The maximum value of this will be when sinus is equal to -1. When sinus is equal to -1, we will have maximum value that is equal to this omega p m. So the maximum value of precession velocity or velocity of precession omega p m is equal to 2p Vm divided by t, the period of harmonic oscillations. Okay, do you have any questions? Do you have any questions about this? No questions. No questions. If there are no questions, I have to clean some space. I have to clean some space on the screen. I have to clean some space and clean some space in order to have enough place to write formula. Okay, let's use this. Maximum value of gyroscopic or more of moment of gyroscopic forces is equal to I omega p m and multiplied by omega. Okay, let's substitute this here and this here and this here. So according to this, m r in second order divided by 2 multiplied by 2 p phi m divided by the period and multiplied by omega. So we have p m r in second order, PMR in second order, phi m omega divided by t. Okay, do you have any questions? Do you have any questions about moment of the gyroscopic forces? Okay, no questions. No questions. So let's clean some space. Let's clean some space. Now we have moment of gyroscopic forces. Maximum moment of gyroscopic forces, and how to find these forces. We have two bearings. And the distance between them is L. And we have two forces. We have two forces. We have two forces that are in parallel directions. But parallel directions, but their moduluses are equal, f vector and minus f. These forces are on parallel lines, but they both are vertical. But first is from down to up, and the second is from up to down. So the directions are different. The directions are different, but both forces are on parallel lines, and the distance between them is equal to L. In this case, moment of these forces, absolute value of moment of these forces is equal to F multiplied by L. And F is equal to M divided by L, and it is equal M. It is equal to P M R in second order, phi m omega divided by LT. Okay, do you have any questions? Do you have any questions? No questions. No questions. Okay, if there are no questions, I'll clean the screen. And the next will be number 16. Number 16. It will be number 16. Number 16. According to the description, a steel ring of radius r rotates around a fixed vertical axis that passes through its center and is perpendicular to the plane of the ring. At what frequency does the ring break? Steel has the density is equal to rho. And the ultimate tensile strength is equal to sigma. Ultimate tensile strength is equal to sigma. Ultimate tensile strength, it is tensile strength when the ring breaks. Tensile strength when the ring breaks. Okay, I'll show the picture. This is the ring. This is the ring. and it rotates. It rotates with angular velocity. With angular velocity omega. The direction of vector omega is perpendicular to the screen, and it is from us to the screen. From us to the screen. Okay, so do you have any ideas? Do you have any ideas of any ideas how to solve this problem, this exercise? No ideas. No ideas. Okay. Okay. So I'll draw vertical line. I'll draw diameter of the ring. Diameter of the ring. This is diameter of the ring. Diameter of the ring. I'll draw this in dash line. This is the diameter of the ring, and I think it is necessary. I think it is necessary to cut a small. It is necessary to have a look at a small part of the ring. A small part of the ring. A small part of the ring that is that is in this angle. Small part of the ring. And here will be angle alpha, and here it will be some small. It will be infinitely small angle alpha. Infinitely small angle alpha. So d alpha. It is d alpha. Infinitely small angle. Why do we need this? We have to find force. We have to find force that is impressed upon this ring. We have to find a tensile force that is caused by its rotation. That is caused by its rotation. And now I want to find this force. And this the radius of the ring is r. The radius of the ring is r. Okay. The force that acts on this small part. Force that acts on this small part of the ring is some force df. It will be It will be df. It will be df. And this small part of the ring has mass dm. Okay, how to find force df that acts on mass dm? How to find the force that acts on mass dm? I don't know. Okay, maybe uh, maybe I'll remind something. If you have rotational motion, we always have normal acceleration, and because of this normal acceleration, we have force df. So according to the second Newton's law, we have dm multiplied by normal acceleration, and it is equal to force df. It is equal to force df. Maybe it is better to sign it as df alpha. ds alpha. It is equal to df alpha. According to the second Newton's law. It is according to the second Newton's law. Okay, do you have any questions? Do you have any questions? No questions. No questions. Okay, if you don't have any questions, let's continue. Let's continue. What can we say about mass dm? Mass dm. We don't know this mass, but we know the radius of the ring, and we know density of this ring. We know density, so we can write that dm is equal to the density rho, density multiplied by volume dv. Volume dv is the volume of this small part, infinitely small part of the ring dm, and it is equal to rho multiplied by s and multiplied by dl. Multiplied by dl. S is square of the cross section of the ring. Square of cross section of the ring. And dl is the length of this infinitely small part. And of course dl is equal to r multiplied by d alpha. R d alpha. RD alpha. Okay, is it clear or not? Yes. Yes, plus. Okay. Okay. If you have written plus, I hope it means that it is that it is clear for you, and everything is okay. Okay. Well. So we can continue. We can continue. So we can continue. And we can substitute this here. We can substitute this here. We can substitute this here, and and uh, and according to this, we have d f alpha is equal to rho s r a n normal acceleration d alpha d alpha d alpha. Well, so we don't know s, and what about normal acceleration? Normal acceleration, according to the description, according to the description, uh, according to the description, we have to find frequency. We have to find frequency. Frequency is connected with angular velocity. So angular velocity is equal to 2p nu. It is connected to angular velocity, and so we have to find angular velocity in order to find frequency. In order to find frequency, and we have to remember the connection between normal acceleration and angular velocity. The connection between angular velocity and normal acceleration. And normal acceleration. Okay. What is the connection between angular velocity and normal acceleration? An is equal to can you remember this? You cannot remember. Okay, I will remind. It is equal to omega in second order multiplied by r. multiplied by r. And let's substitute this here. It is equal to rho s omega squared r squared d alpha d alpha d alpha. Okay, and now we have to find the projection of force df alpha, on vertical direction. We have to find the projection of force df alpha on vertical direction. So why do we need this? Because we have when ring rotates, we'll have tensile forces, tensile forces, tensile forces, tensile forces, tensile forces, tensile forces df, no, df, f, f divided by 2 minus f divided by 2. Here we also have minus f divided by 2 and f divided by 2. F divided by 2. And we have to find f from df alpha. How to do this? df, how to connect df and df alpha? Df and df alpha. We can see that here we have the angle that is equal to alpha. That is equal to alpha. And what can we say about the angle alpha? What can we say about the projection? According to this picture, here is df alpha and here is df. df, this is df alpha, sorry, df alpha, and here this is df, and here we have the angle alpha. Okay, and from this, how to find df? How to find df from this? df alpha, yes, but df alpha without vector on it. Df alpha without vector. Yes, that's okay. Yeah, okay, yes, the alpha multiplied by sinus of the angle alpha. Yes, that's correct. That's correct. And according to this, we have rho s omega in second order, r in second order, sinus alpha d alpha. Yes, and now we have to integrate this. df is equal to integral rho s omega in second order, r in second order, sinus alpha d alpha, sinus alpha d alpha. Okay, and what about integral limits? What about integral limits? The integral limits for the force, it will be from 0 to the whole force f, because f is force that acts on a half of the ring. And here I will write this sign in order to have different signations in the integral expression and integral limits. And what do we have here? We have to pass all angles for this half of the ring. We have to pass all angles alpha for this half of the ring. The smallest angle is equal to 0. And the biggest angle, the largest angle, is equal to p radians. It is equal to p because for upper half of the ring, it will be the angle alpha will be from 0 to p. Okay, what about the integral in the left side? Yes, it will be f. And in the right side we have integral from 0 to p. Rho s omega in second order, r in second order. Maybe I will I will calculate it separately. I will calculate it separately because rho, s, omega, and r are constants. So all we have to calculate is this sinus alpha d alpha. Okay, so how to find this? According to the table of integrals, it is equal to minus. It is equal to minus cosine alpha from 0 to p. So it is equal to minus cosine p minus cosine of 0. Cosine of 0. And it is equal to minus, open the bracket, minus 1, minus 1, and it is equal to. It is 2. So from this we have f is equal to 2 rho s omega in second order r in second order. R in second order. R in second order. Okay. Okay, do you have any questions about this? No questions. No questions. So we have found the force F. It was the most difficult part of this exercise. It was the most difficult part, and now all that we need is to find tensile strength. Is to find tensile strength. All we need is to find tensile strength. Tensile strength, because we have the force F, and to find tensile strength, we can see that here we have half of the force F, the cross section of the ring is S. So according to this, we can write that tensile strength is equal to F divided by 2S divided by 2S, and according to this, it is equal to double S will vanish, and in result we obtain rho omega in second order, r in second order, r in second order. Omega in and r in second order. And from here we have omega is equal to sigma divided by rho r in second order under the square root. We can write in this way. Sigma rho, and because r radius is always positive, so we can write that it is equal to sigma divided by not r, sorry, it will be rho. It will be rho, and we can remember that frequency is equal to omega divided by 2p and it will be 1 divided by 2p r. R looks similar. Sigma divided by rho. Okay, do you have any questions about this exercise? Do you have any questions? No questions. Okay. So the next homework will be numbers. Number 13 and number 15 and number 15. And I have to remind that these homeworks are necessary to be done. They are necessary to be done, so don't forget to do them and to send them to me. The solutions of these home exercises. Okay, do you have any questions?
No, teacher.
No. Okay, so thank you for your attention.